So, going back to the tutorial outline here, um, we've now seen some of the basic single table operations, queries, sorts, and summaries that allow us to create and explore associations and distinctions amongst uh, things and conditions and ideas stored as rows and tables. Now the next phase is going to go into table join operations, one of the fundamental operations of relational database management tools that allow us to use multiple tables to explore the relationships between different kinds of things, conditions, and ideas. And the demonstration that we'll do now is all about lookup tables, which is a particular application that it's very handy for dealing with categorical data and transforming it. Why would we want to do that, you may be wondering? Well, let's say we want to make a map of land use to support a discussion of something specific. So, for example, I may be interested in comparing the land use change between Somerville and Cambridge. We could make a map and we could show all 37 of these categories using our ready-made land use layer. But really, when you make a map like this, when you're trying to communicate with people, being concise is something you should shoot for. And when you're comparing land use in Somerville and Cambridge, you don't need cranberry bogs, and you may not need to necessarily distinguish between all these different kinds of residential. You want to make sure that your land use legend, has fewer than 8 or 9 distinctions in it, so that you're not just confusing people unnecessarily. So, how can we do this? The brute force way of recategorizing a data set like this would be to go into the legend editor. I'm going to the properties for this land use 1999 layer that we got from MassGIS. Go to the symbology tab, and let's say for my exploration, cropland, pasture, forest, non-forested wetland, mining, and open land are all considered to be open land and utility. Let's just say open land. I might also lump in saltwater wetland into that. So I'm control clicking these. And I can lump them all together by right clicking and saying group values. You see, now I've taken 7 of my individual classes and lumped them all into one class, which we could call open land. And you need to worry about what you're naming these. This naming categories is a very powerful thing, and you don't want to be careless about it. I'm being careless right now just because I don't want to waste too much time. But this way of recategorizing in the legend editor is very quick and easy when you get started, but as a general practice, it's not very helpful. For one thing, if you decided that you wanted to take mining out of this, you would have to right click to open this group again and say ungroup values. But now we've lost all of the distinctions that we had before, and in order to figure out what mining is in this, we would have to go back to the metadata and look, and this becomes a real headache. So people who understand how to use relational databases have a trick called lookup tables, which is a good demonstration of relational joins. I'm going to illustrate this by going back to the attribute table for our land use 1999 layer from MassGIS. Notice it's a fairly short table. We've got area and length here, it's the last 2 columns, and we have things represented. The things represented are polygons uh, that were land use areas identified by aerial photographic interpretation. Each polygon is associated with a reference to a land use category. So here's a polygon that was 6 in 1971 and 3 in 1999. Now, these categories you can think of as ideas. We have things here, actual things representing places on the ground. We have this condition here, which is a 3. If we look into the metadata, we can see that 3 was forest, 6 is open land. So apparently somebody cut down some trees. We could kind of figure out where all that happened if we wanted to. But these categories now, you could think of them as ideas, or you could think of them as abstract conditions, right? These are conditions that could be happening everywhere. When you look at the table, you see this is a specific condition happening in a specific place. So the relationship between observations and ideas could be seen as relationship between two tables, where this table has the ideas and the other table has the observations in it. So here's the nifty trick of the day. We're going to select this handy tabular list of ideas from the MassGIS metadata. I'm going to type Control-C. Now I'm going to open up Excel, and I'm going to right-click in here, and we'll try different paste options and see. Looks like the second one does better. So I'm using Excel to create a table here. It's doing a pretty good job. The table columns don't have any spaces in them, which is good. No column names begin with a number or have any kind of special characters in them. We can remove the blank columns here. We'll spread out the width so that all of the values are in here. I think there's an automated shortcut key for doing that so that the width of the column fits the content. And with a table this small, it's not too hard. Whoopsie daisy. And so we have now this table in Excel, and it's a worksheet. We'll just rename this worksheet for the heck of it and call this LU_codes. But I want to say that this table reflects if you want to know the things that are represented here, the thing is a code or a land use categorization. It's not really a thing, it's just kind of a collection of ideas about what different kinds of land uses might be. So take a look at this. Codes 10, 11, 12, and 13 are all residential according to the category. But if you look in the definition, you see that the code for 10 corresponds with an observation of multifamily, 11 smaller than quarter-acre lots, and so on and so forth. So there's 4 types of residential, and they break down like this. And so this is a very interesting kind of set of relations between codes and ideas about land use. So and any idea can be stuck in here, which you'll see is pretty handy. So we've got this Excel spreadsheet, and I'm just going to go ahead and save it. We could save it as a CSV file, or I can save it as an Excel file. I'll put it into my project folder here in CTemp. and I have my data folder where I've actually put some lookup tables in here already. You see I have the LU21 LUT XLS in here. I'll replace it with this one. And we can quit Excel now to minimize it and go into ArcMap using the Add Data button to go in here to my project folder. Here's my Excel table and some other drafts that I'd made earlier. Now when you open an Excel table in ArcMap using the Add Data button, there's actually this is a container because an Excel worksheet can have multiple, or an Excel worksheet can have multiple tables. And so we see inside of this, here's my LU codes table. We can open that here, and ArcMap, you now have actually witnessed ArcMap is able to exchange tables with Excel. So that's quite handy. You can read in my notes, there's a bunch of do's and don'ts associated with that. And it works, but ArcMap doesn't really like to work on Excel tables. It can read them fine, but if you try to edit them and do too many things with them, it gets complicated because it's both Excel and ArcMap are skittish about actually working on tables while they're being worked on or even looked at somewhere else. And so it's a good process. So for example, you see you can't add fields here if you pull down this menu. So what we do is we're going to export this table as a DBF, which ArcMap likes to work with much better. You can do that either from the table menu, or you can do it by right-clicking on the table in the table of contents and choosing export, or actually choosing data export, which is off of your screen right now, but we'll do it from here. Export, make this a DBF, dbase. You can see I've already sort of made a couple of them here, and we'll just call this LU21 LUT3 PBC so that you can see that there's nothing hidden up my sleeve. And we'll add that to the view. So now we have my land use 21 code lookup table number 3, and I'm going to get rid of the Excel spreadsheet here, and we can open this. You'll see, well, that was a mistake. It only exported one record because I had something selected when I exported that from Excel. That's kind of a big gotcha. Let's do this again very quickly. Make sure before you do your export that you go to the selection menu and clear selected features. Now we can export this, and we'll export it as a DBF, which is a very stable and exchangeable and easy to handle table exchange format. So we'll call this LU21 LUT4. Okay, removing the Excel table, we'll remove number 3, and now we can open our lookup table number 4. So we now have a system of tables here, and to sort of sort this out, it's helpful to be able to have two tables open at the same time. So I'm going to shrink this a little bit, and I'm going to now open the attribute table for my 1999 land use. So we have one table open here, my lookup table. I right click on this land use layer, say open attribute table. So now you see we have two tables open in this table browser. There's my lookup table. There's my land use table. Now I'm sort of going into this. This is not necessary to do this in order to do table joins, but it's very helpful to have these two tables open when you're sort of exploring how a join might be done. It's also helpful to be able to see two tables at the same time. So here's how you do that. I'm going to take from this tab down here and take my lookup table tab, drag it in. You see these handles appear, which are the sort of docking handles. I'm going to touch the bottom one, so my lookup table will appear here. My polygon attribute table is on top. And let's look at this. I'm going to use some new relational terms here to talk about the relationships between this table as a representation of observations and this table as a representation of categories. And we can see that each category in the lookup table is 21 rows. Each category is referenced by a code, and this is the meaningful code. This code is unique, and no code appears more than once. The code is a way of referencing this collection of attributes, which are sort of subcategories of land uses. And so, for example, if we find a polygon in the polygon table that was coded as 11, according to the 21 class land use scheme, we can find out what 11 means by looking it up here. And we see 11 is smaller than quarter-acre lots. This is why they call it a lookup. This column is a set of references to the key of this table, the unique key of this table. This is known as the foreign key here. This is known as the unique key in the lookup table. And so I can set up a relationship here where I can say these attributes are associated with the rows in this table. The parent, or the attribute table, or we could call this the target table, is going to have new columns joined to it according to this rule that 11 in LU21 1999 matches with 11 in code here. And so that's the idea of a join. And in the normal SQL tools, you can just type this out as an SQL script. In ArcMap, the way that you do it is you right-click on the table that you want to be your target. In this case, it's the land use attribute table. You can go to Joins and Relates and say, Join, please. And we can answer these questions. I prefer to answer the second question first. Choose the table to join to this layer. That's going to be our LU21 LUT4. Now choose the field in this layer that the join will be based on. That's going to be LU21 1999. And then, this is very important, choose the field in this table to base the join on. Now, it's suggesting OID, which is the object ID, and that would work. It would just be, unfortunately, completely wrong. You may not even notice that it's wrong, and so it's very important that you sort of pay attention when you're doing this. You want to join on code because these codes are what match this. Now OID would also match. It would just happen to be completely scrambled, so be careful. So here's my join dialog. And what's going to happen is this is going to create another relational view. Keep your eye on this table here. Right now you see it's only got these columns in it. Now I'm going to push OK. ArcMap offers to make an index for me. Sure, thank you very much. Now you see I've got more columns here, and I have for each of my land use observations the set of ideas about how that particular code can be interpreted in different ways for different purposes. We have a fine-grained definition, and we have a more coarse definition. If you look at these two residential things, and now those are embedded right onto the polygons. And the beauty of that is, be careful now, you should always, before you leave a situation like this, just go up to the selection menu and say clear selected features. You saw how that snagged us before. You want to sort of, the way to be most sure about what's selected is to just go up and go to the selection menu and say clear selected features, so that you know what you're working with. And so, having done this lookup, we now have a handle on categories. I'm going to make a copy of this layer again, because I don't want to mess up my original MassGIS layer here. So we'll copy this. I'm going to change my table of contents back to list by drawing order. We paste this copied layer into the data frame. So like before, we now have two copies of the same layer. They're identical. This one I'm going to change to land use simplified. Okay, so the original was 37 classes. This land use simplified is still 37 classes, but we're going to simplify it. So we'll double click here to get to the symbology properties. Instead of choosing the value field 1999 37 classes, you see now I have category, and I can add all values here, and you see that now with my categories I just have one residential category instead of 4. I still have too many categories here. I still have too many for making a map, and so I want to do some simplification, and I'm not going to do it here in the legend editor. I want to be more systematic about it, about my reclassification. And you should probably start having a premonition about how I'm going to do that. The way I'm going to do it is to go back to my lookup table. We'll open this. I'm just going to remind myself that my lookup table, when you open a table, if it has nothing in it, it may be because you need to show all records. So the lookup table is a place for attaching ideas about categories to these codes. And so you saw how I started to lump those together in the legend editor. Now what I'm going to do is I'm going to lump them together here by creating a new field on my table. Going to the table menu, add field. You see the different kinds of fields that you can have in a DBase table include short integers, long integers, floating decimal numbers, double precision decimal numbers, text fields, and dates. So all these different types of data fields have different logic that applies. We want to choose a text field, and I'm going to call this PBC simple LU. And we'll let each land use category name have 50 characters in it. I think I might be able to get away with 30. And here's an interesting thing. Of course, as we mentioned in lecture, a DBase field can't have more than 10 characters. I think there were 9, I can't remember. But so ArcMap warns us about that. Do you want to rename this to PBC Simple? Sure. So we have a new column here on this table of category translations, also known as a lookup table. And so I'm going to make my own simple ID here, or simple category description. I'm going to start with category. This is a good place to start, I think. So I'm going to come over here and calculate the values by right-clicking on PBC Simple, going Field Calculator. It's going to warn me about how this can't be undone. I'm okay with that. And so here's another SQL expression. In this case, in the real SQL world, this would be called an update query. And what we're going to do is update the values of PBC Simple, and we can base that on an expression. I could say update those values to be whatever the value is for category for each row, push it into the value of PBC Simple. So I just selected category from here, and OK. So you see, I've just calculated this. One big gotcha here you want to watch out for is in ArcMap, you should never do this when you're in layout view. If you discover odd behavior when you are updating rows in a table, it's maybe because ArcMap has a bug that causes that to do wacky things when you're in layout view. So I'm in data view here. Now we'll lump together these categories as we did in the legend editor. I'm just going to take these top 6 categories, and I'll go ahead and control click on waste disposal for landfills, and I'm going to calculate these values just to be open land. So with these rows selected, you see I've got just these rows selected, I can come up here to the calculator. It's warning me again, okay. And now instead of pushing in the values from another column, I'm just going to type double quote open land, close quote. And when I push OK, you see I've calculated all that to be open land. These residentials are too clumpy, so I'm going to say I want to just have multifamily and single family. So I'm going to leave 10 as multifamily, but 11, 12, and 13 I'm going to recode to single family. And so we'll do field calculator for these. This will be single family. A lot of times if you get an error when you push OK on this, it's because you've used the wrong type of quotes or you've failed to keep your quotation marks symmetrical. This guy here is multifamily, and so I can calculate its value for this row. Being a lazy guy, I'm just going to say take the value from definition. Okay, so that's going to cause multifamily to be put into this single row. Okay, so salt wetland and woody perennial are going to be natural areas. Oh, see, there's a failure. It doesn't tell me why, but if you go back and you do this calculation again, you'll see that I just forgot to put the quotation marks in there. Okay, so finally, we could take, for example, I'll just get this over with and take the different recreations, water-based, spectator, participation, and even though I'm probably doing being too careless with this, and you definitely want to take care when you're doing this, we'll just call all of these recreation. You honestly don't want to take these categories at face value without reading the metadata, because these names are very simple, but a lot of times they're lumping together things. For a particular purpose that you have, you may not be wanting to lump these together. but I'm just doing the technical bits here. So now this table has my own category scheme in it, and we can take a look at this, our land use simplified layer. If you go to the attribute table for it, you'll see that we now have our own class on here. We haven't rejoined this. It's still that having modified our lookup table now apparently modifies this view, which is the join of our polygon attribute table to the lookup table. And that's why this name for this column has gotten the name of the table prepended to it. I'm not sure why these also don't have that. And there's something a little odd that happens next. We might hope to go back in here and find that row, that new column in our value field, but we don't. And this will give us another opportunity to explore another way of looking at joins. I believe what we have to do is rejoin this. We can go here to the way we joined it to begin with, right-clicking on Land Use Simplified, Joins and Relates, and we could remove this join here. But I'm going to show you another way of managing joins. The way you mostly do it in an ad hoc way is to use this right-click menu. But you can also see, by bringing up the properties for this layer, that joins are another layer property. And you can see this join here, LU21 for PBC, which was joined before we added our new column. And we can remove that and simply add it again, being careful to choose the correct table and the correct foreign key and the correct unique key. And then that join is here. We can look at the attribute table here, and I think it's going to look a little bit cleaner. See, these column names, I don't have that funny distinction on them anymore. And then we can come back to the symbology editor, and we have PBC simple here. And now we have a nice concise legend, right? We've got fewer than 10 distinctions going on, and I can order these. I often order these in order of intensity, and we can apply our classic land use colors. We want to engage with the conventional land use colors, which are discussed in a web page linked to this. Industrial, for example, should always be purple, or else people are going to get frustrated when they're looking at your maps. And I won't take the time to do that right now, but I just want to just pause and think about the way that table joins allow us to manage the connection between, or relationships between, things and conditions that may be of different types. And this is quite a powerful way of modeling the world and doing experiments. I can leave it to your imagination now to think about how you might compare Cambridge and Somerville based on these new simplified definitions. Maybe I'll demonstrate one more thing here in that regard. Let's say, for example, I want to compare Cambridge and Somerville land use change. And so we have here, for example, land use simplified, and this is land use simplified from 1999. Now, what if we want to do land use simplified for 1971? Let's turn that off. We've got land use simplified 1999. So now I'm going to copy this and paste it up here. And this guy, switching over to list by drawing order, we're going to call this Land Use Simplified 1971. Now it's still actually 1999, and the way we can see that is if we go to the layer properties and look at the join, we can see that this is actually applying my code definitions to the 1999 land use. So if we want to change this to the 1971 land use, then I can go up here and remove this join and just add the new join. And instead of choosing the 1999-21 codes as my foreign key, I'm going to choose LU21 1971. That's still going to match to code, right? So we're using the same lookup table. We're applying it to a different year of observations. And so this may give us a quick look at change. It's a little hard to see when they draw in slowly, but if you look at my web page here, you can see how I've got the 1999 simplified and the 1971 simplified. And you can see how they aren't the same, and there's definitely some interesting patterns going on. So I'm going to do one more thing, and I'm going to get into a little trouble just to show you what that feels like. You should always expect trouble, actually. Let's go the extra mile here, and I'm going to jump out and call this Land Use Simplified Somerville. Now, how do I do that? Well, what I can do, you know what I can do. I can go in here and change the definition query. And I'm going to go to my query builder, and I'm going to say, let's filter this table so that the tile name, we're going to select those polygons whose tile name is equal to Somerville. Now, I looked up Somerville. You can do this too. If you go to the towns database, the towns shapefile here, you can see for each town there's a polygon, and this town ID sort of reflects the code for each name. So you see this is another table with another set of things. They call these a feature class because each one of these things is a particular type of feature, a polygon, distinguished by all these attributes, including town name and town code, and we can see that Somerville is 274. Now notice how I said that. I said 274, and that should trigger something. There's something odd going on here. But going back to my land use simplified 71 Somerville, we'll go to the definition query, and I'm going to say, well, let's take a look. Let's make a file, a table view that only regards those land use polygons that happen in Somerville. So I can say, select those rows from land use poly where tile name equals 274. He types. And we'll click OK. And I can click OK on this. And, ooh, a drawing error. Land use, an invalid SQL statement was used. What could possibly be wrong with this? Here's the gotcha. If you look at the attribute table, the attribute table is unhappy, actually, because of this error. Let's go back and we'll just remove this definition query right now. If you look at the attribute table for this layer, you'll see these columns Tile name is numeric, right? Those are all numerals. Like LUID and these codes, we've been treating them as numbers, and you can right click on a code and look at the properties and see that's a long integer type. Now, even though tile name is using numerals, if you look at the codes, if you look at the properties, it's a character string as a data type. It just happens that all the characters are numbers. So don't be confused. When you treat this in a query, you have to treat it like a text string. And you might not see that off the top of your head. That also applies when you're looking at joins. You can only join a numeric field with another numeric field, a text field with another text field, and so that can sometimes lead you into adventures. So let's go back to our definition query here. A quick way around that, because it's not always obvious, is you can say, I want to select those rows where the tile name equals. Now I could, knowing what I know now, put this into quotes, and in this case it's single quotes, which will always get you. You never know when to use single quotes or double quotes. You would simply have to guess. Now I could enter that in there, but a quick way of getting this is to say, instead of typing the tile name, you select the field here, and then you push the Get Unique Values button, and now you can see how it wants you to address these keys. And I'm just gonna scroll down and pick 274. This appears in the table like that, and it puts the right quotes on there and everything. And so this definition query now will allow us to look at the simplified land use change just in Somerville. Aha! And so there's all kinds of nifty things that you can do with this, including changing the symbology so that's highlighted and everything else is more subdued. You know, you could take the non-trimmed, non-defined thing and make it more transparent. We'll just quickly do this. So I can go to symbology, no, display. I'm going to make the background the all 1999 values, and I'm going to make that 75% transparent. So you'll see when this draws in, see how Somerville now stands out and everything's ghosted. That's a nifty technique there. But also this view will allow me, this is now just the Somerville polygons, and I could take a summary from this using my simplified categories. And so we'll just do this quickly. Sum up the acres for each of my PBC simple classes, and we'll stick that into my Scratch folder, and we'll call this Simple Somerville 1971. Those were the days. Okay, an error occurred. The error occurred because I'm trying to make a DBF, but ArcMap doesn't see the DBF suffix, and it thinks that I want to put it in a geodatabase, but it should be a DBase table. So there you have it, this amazing adventure through relational tools. Here's my summary, and the land use in Somerville in 1971, and I could make a chart out of that in Excel or something like that to show the comparison. Cambridge, Somerville, 71, 99, and have control over these categories. So just to recap this, relational database tools are a standard invented by a guy named Codd in late 60s. They've become the way human beings represent things and conditions, ideas as rows in tables, and operate on them with a set of logical tools. used in most database management systems. Uh, and once you learn how to harness this, you can learn a lot of things about observations that people have made and saved for reuse. So have fun, and we will see you in class.